Okay, number one, if the two triangles are similar, what is the value of x and y? Leave your answer in the form of a fraction. Now, some of you were a little confused by when I wrote down the proportions when we wrote down the big picture using words. So in this homework, I'm going to use colors. All right, I'm going to call this side the blue side of the small triangle, and this one the blue side of the large triangle, the big triangle. So that should be easy to see. And these sides correspond to each other. And then over here, I'm going to call this the red side. Oh, that's not nice. The red side of the small triangle, and this will be the red side of the big triangle. Ah. And now I have to set up my proportion. Now I said all you have to do is compare similar features. So there's two ways to do this. There's actually more than two ways to do this. I'm gonna go through. I'll go through two. So the first way would let's do this. The blue side of the small triangle compared to the blue side of the big triangle. So blue side of small triangle to the blue side of the big triangle. And that should be the same proportion or proportional to the red side of the small triangle to the red side of the big triangle. All right. Over here on the left side, we are comparing the blue side of the small to the blue side of the big. Over here on the right side, we're comparing red side of the small, red side of the big. Our small triangles are on top, our big triangles are on the bottom, blues are on the left, reds are on the right. All right, that makes sense. That's a valid proportion. All corresponding sides and all corresponding features are grouped together. So, now that we have our proportion, we just fill those ideas in with actual numbers. Doesn't matter what the numbers are, as long as you have the right proportion. So the blue side of the small triangle is 1 1/2. Yay. The blue side of the big triangle is 2 5/6. 2 5/6. And that should be the same proportion as the red side of the small triangle, which is 2 2 2/5. 2/5. And then the red side of the big triangle is, we don't know, that's just x. And so all we have is a multiplication problem and then a division problem. Multiplication and then division. We're just cross multiplying. So multiplication first. 2 5/6 times 2 2/5. Now we're eventually going to have to divide, so I'm going to turn these into improper fractions. That's probably the easiest way anyway. 6 times 2 is 12, plus 5 is 17. That's 17/6 times 5 times 2 is 10. 10 plus 2 is 12. That's 12/5. And that gives us a fun number. 17 times 12 is 204 over, and 6 times 5 is 30. All right. Now we have to take 204 over 30, and we have to divide that by 1 1/2, which we're going to turn into a mixed number. That's 2 times 1 is 2, plus 1 is 3. That's 3/2. Now you know, when we're dealing with fractions, every division problem is really just a multiplication problem in disguise. So we take the reciprocal of 3 over 2, which is 2 over 3. 2 over 3. And then we do that. 204 times 2 is 408. And 30 times 3 is 90. And there's our answer. And all we do is we turn that into a mixed number. 408 divided by 90 is 4. And this is going to be fun. 4 times 90 minus 408 is 48 out of 90. Divided by 2. This is 24 over 45. I guess that's 24 over 45. And this may be able to be reduced further. Let's see, that's 6, that's 4. That can't be divided by 6 or 4. All right, I'm going to leave it like this. If you can reduce this further, yay for you. 4, so x equals 4 and 24 45, or 4 over 45. Now, if you wrote 408 divided by 90, if you wrote this, 4.53 bar over the 3, you would not be wrong numerically, but you would be wrong in terms of how the question wanted you to answer, or give your answer. It said leave your answer in the form of a fraction. So you do have to read the question. You do have to adhere to it. If they want 4 and 24 45ths, then that's what they want. It may be an ugly number, but that's what you got to do. But I know a lot of you like to deal with decimals. If you dealt with decimals and got something like this on a multiple choice test, you should be able to recognize that 4 and 24 45ths is the same thing. So if you're more comfortable dealing with this, that's fine. I'd rather you get comfortable with fractions, because when you deal with fractions, you don't lose precision, and when you deal with decimals, you do. But for the purposes of the MSA, I guess if you got this and you can recognize that these are equal, then that's fine. Okay. Oh, and I promised I would do this a different way. So another way I could have done this is the blue side to the red side of the small triangle. Blue side of the small to the red side of the small. And that should equal the blue side of the big triangle to the red side of the big triangle. Now, over here, notice, well, in this one, we were comparing blue side to blue side, red side to red side, small on top, big on bottom. Here, we're comparing blue to red of the small triangle to blue to red of the big triangle. Still, we're comparing the same features in the same way, so our proportion is valid. And if you plugged in the numbers here, that would be 1 and 1/2. Oh, I'm running out of space. Red side, that'd be 2 and 2/5. And that equals blue side 2 and 5/6 over, we don't know, that's x. Now notice, we multiply 2 and 2/5 by 2 and 5/6, which is exactly what we're doing here, except in the opposite direction. But since multiplication is commutative anyway, it doesn't matter because you get the same thing. And then we're dividing by 1 and 1/2, but we're dividing by 1 1/2. So it's the same calculation. You'll get the same value for x. Moving on, let's figure out what y is. We need another color. Let's use green. So again, you could call this the base, you could call it the green side, you can call it whatever you want. Just remember that the base is just, any side of a triangle can be the base. If you were to rotate the triangles, or just turn your head. So we'll call this the green side, and now let's set up a proportion. At this point, you can do it any way you want. I'm going to do it one way to save time. Okay, so I'm going to compare the blue side of the small triangle to the blue side of the big triangle, blue of the small to blue of the big, and that should be proportional to the green side of the small to, oh, I hope you can see that, green side of the big. All right, now that I've set up my valid proportion, I have my big picture, I can fill in my numbers. That's 1 and 1/2, 1 1/2 over the blue side, that's 2 and 5/6. That should equal the green side of the small, that's 3 and 1/5 over, and we don't know why. Multiplication, division. I'm going to skip a step here. I hope you can follow what I'm doing. I'm going to turn these mixed numbers into improper fractions. 6 times 2 is 12, plus 5 is 17. That's 17 over 6 times, that's 16 over 3, 5. And then 17 times 6, 16 is, 272 over 30. And then we're going to do the same thing that we did before. 272 over 30 divided by 3 halves. That's 1 and 1/2 converted to an improper fraction. So that's multiplied by 2 over 3. I'm just taking the reciprocal of the improper fraction version of 1 and 1/2. So 272 times 2 is 544. Oh, we're going to get another fun number. 30 times 3 is 90. And then you turn that into, I guess technically, I would also accept, I said leave your answer in the form of a fraction. If you left your answer like this, I wouldn't be overly happy. If you left your answer like this, that's fine too. But you might as well go through the trouble of turning it into a mixed number. Divided by 90 leaves you with, oh, God. All right, that's going to be weird. All right, 6 and 90 times 6, and that's 4/90ths, which is 2/45. 2/45. 2 divided by 45. Let me just double check. No, that's wrong. 2 divided by 45. Yeah, there we go. Okay, well, that's a fun answer. Doesn't that look fun? All right, y equals 6 and 2/45. All right. Yay. If you got something, I think it's 6.04 bar. If you left your answer like that too, you're not wrong, but you didn't follow instructions. All right, moving on to number 2. As you can tell, fractions do take a long time. That's why you don't like doing them. That's why no one likes doing them. However, you need to know this. You use it all the time in Algebra 2, all the time in geometry, all the time in every higher math class. So just, you got to deal with it. Number 2. Dora is making brownies to serve at the family picnic. If the recipe calls for 2.5 cups of cocoa to serve 4 people, how many cups will she need if there will be 60 people at the picnic? Okay, it's very simple. All right, set up your big picture. We are comparing cups of cocoa, no, that's wrong, cocoa, to people. All right, numbers of people. All right, numbers of people. All right, so no. So cups of cocoa. This will be the recipe, and this will be what she needs when she bakes it. All right, what she bakes. So the cups of cocoa in the recipe call for 2.5 cups. 2.5 cups for every 4 people. And that is in proportion to how many cups she needs, we don't know, for 60 people. Notice, right? This is the same thing that I did over here. I'm looking at the big picture. See, blue to blue, red to red, small on top, big on bottom. Here we've got cups of cocoa to number of people, cups of cocoa to number of people, cups of cocoa to number of people, cups of cocoa are on top, number of people are on the bottom. It's the same thing. You could set this up in a different way. You could do cups of cocoa to cups of cocoa, number of people to number of people, with the recipe and the real life on the bottom, recipe on top, real life on the bottom. Any way you want to do it. Just make sure that you're setting up your proportion correctly, because if you don't, you're going to get the wrong answer. So let's do it. All right, cross multiply. 60 times 2.5 divided by 4. 60 over 1 times 2.5, which is 4, 5 halves. 5 halves. That equals 300 over 2. Don't simplify it yet, work with fractions. 300 over 2 divided by 4, which is just times 1 over 4, which is 300 over 8, and now you can simplify that. 300 divided by 8 is 37.5, which is 37 and 1/2 cups of cocoa. Oops, let me use the right color. 37 and 1/2 cups of cocoa. Now, 60 times 2.5 divided by 4, you get the same thing. Most of you probably used your calculator and converted 2 and 1/2 to a decimal, 2.5. You did 60 times 2.5 divided by 4. You're going to get the same result. However, get used to working with fractions. You get the same result this way. And you get practice using fractions. All right. Anastasia needs to run some errands. She leaves from home and heads to the bank first. Bank first. Because she needs to get there before it closes. Then she goes shopping at Macy's. Then she heads to Macy's. Because, well, it's shopping, and shopping's fun. Finally, she goes to Safeway and picks up food for the week before she heads home. All right, so then she goes to Safeway, and then she heads home. Using the information in the map below, how far did she travel? Ooh, look at this. If 1 inch equals 3 miles, and to go from one cross street over here is 1.5 inches, and to go from here north is 0.75 inches, we just have to figure out how far did she travel on the map, and use this ratio, or this scale, to find how many miles she traveled in real life. So let's add it up. She started at home and went to the bank. To get there, she would have had to travel 1.5 plus 75. I'm sorry, plus 0.75. So let's start adding them up. 1.5 plus 0.75, and I'll put a little 0 there, gets to the bank. Then she heads to Macy's. So she goes to the bank all the way to Macy's, that's another 1.5. Then she goes from Macy's to Safeway. To get to Safeway, she has to go across 1.5 and down 0.75, or down 0.75 across 1.5. So either way, she's traveling another 1.5 inches plus 0.75 inches. She gets to Safeway, and then she heads back home, which is another 1.5 inches. All right, isn't this fun? Let's add all this up. 5 plus 5 is 0. I'm sorry, it's 10. And then we've got 6. 6 plus 7 is 13. 13 plus 5 is 18. 18 plus 5 is 23. 23 plus 7 is 30, and that's 35. 1 plus 3 is 4. 5, 6, 7. That is 7.5 inches. So she traveled 7.5 inches on the map. Now, let's set up our proportion. What we want is inches to miles, right? Inches to miles. Inches on the map to miles in real life. Inches traveled to miles traveled. Alternatively, we could do inches on the map to inches in real, inches on the map, well, no. Let's keep it simple. So, inches on the map, all right, 1 inch equals 3 miles. We traveled 7.5 inches. How many miles is that in real life? So that's 7.5 times 3 divided by 1. 7.5 times 3, that's a total of 22.5 miles. Easy enough. Number 4. Claudia has recently graduated from college. She got a job at a bioengineering firm and used the money from her first paycheck to buy $3,000 worth of Pepco stock. This was at the beginning of 2010. At the end of 2012, the stock was worth $3,450. Claudia is saving for retirement. If the return on her investment remains constant, and she plans on retiring in the year 2040, how much will the stock be worth when she retires? How much money did she make on her initial $3,000 investment? Interesting problem. Now, since we're using proportions, some of you may do this. The stock was worth $3,450 in 2012. So how much would it be worth in 2040? This would not work. And I'll tell you why. Because the number 2012 and the number 2040 does not show you or represent the right proportion that you're dealing with here. What we're dealing with is a span of 30 years, or I should say we're comparing the growth of the stock over 2 years, from 2010 to 2012, over the growth of the stock over 30 years. And these numbers don't show that. So the proportion between 2012 and 2040 is going to be relatively small. It's not going to give you the right answer. So what you want to do is you want to set up your proportion, right? Growth of the stock, or how about what's an easy way to say it? Let's say growth. Growth over years. How much does the stock grow over a certain amount of years? Well, we know over 2 years, we started at 3,000 at the beginning of 2010, and we had $3,450 at the end of 2012. So we know that it grew $450 in 2 years. $450 in 2 years. So assuming the return remains constant, assuming this trend continues, then how much will the stock have grown in 30 years? That should be proportional. So let's figure that out. 30 times 30 times 40 divided by 2 is 600. That's not right. 30 times 450 divided by 2. That's better. Okay. X equals $6,730. Well, that's a pretty nice return. $6,730. So that's how much the stock has grown. Remember, growth over years. How much will the stock be worth when she retires? Well, it was originally worth $3,000, and it grew by $6,730. So it's going to be worth $9,730 when she retires. That's pretty good. You put in $3,000, you don't worry about it, you take out more than 3 times the amount. That's nice. How much money did she make on her initial $3,000 investment? Well, it grew by $6,730, so she made $6,730. And you're going to have to pay taxes on that, and that's fun. And while I have your attention, I'm going to show you the thing about stocks is they don't grow at a constant rate. They grow, they don't grow at a constant rate, but even more importantly, they grow by percentages. So you can't think of stocks growing at a certain rate per year. So imagine we start at $3,000 the first year. All right. The second year, let's say it grows by 6%. So that would be $3,000 at times 1.06, let's say 6.5%. Okay, so if the stock earns 6.5% every single year, after 30 years, it would grow to $18,632. That's after 30 years. You just put it in and you let it grow. That $3,000 grows to $18,632. Now let's say the stock grows at 6.5% a year, but every single year you invest another $3,000. Let's say you take that first paycheck and you just dump it into that stock. Now, the same stock, just putting in $3,000 per year, that first paycheck, all right, your $3,000 plus all your cumulative investments, after all that time, after 30 years, you would have in your portfolio $259,124. And that's at the stock growing just, well, I guess not modest, but an average of 6.5% a year. Look at that. Moral of the story, saving money and investing it equals good idea. Moving on. Number 5. In the year 2000, there were 8.7 deaths per 1,000 residents in the United States. If there were blah, 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 blah residents in the United States during 2000, during the year 2000, how many people died that year? Oh, how morbid. I got this from a list of questions. Don't blame me. Okay, so we are comparing deaths per residence, or I should say population. Death to residents. Deaths for every residence. So there were 8.7 deaths for every 1,000 residents. If we don't know how many deaths there were for 281,421,906 people in the United States during that year. So I'm not going to require you to do this by hand. You can use your nifty calculator. 281,421,906 times 8.7 divided by 1,000 gives you 2,448,370 and then 0.5822. You can round, it really doesn't matter at this point. Round up, round down, do whatever you'd like. It's it's just an estimate. So that's your answer right there. Number 6. In a shipment of 400 parts, 14 are found to be defective. How many defective parts should be expected in a shipment of 1,000? All right, well, this is simple. We are comparing defective parts to units in a shipment. Units in shipment. All right, so there were 14 defective parts in a shipment of 400. How many parts were there in a shipment of 1,000? You understand? This is why I always think big picture first, because then I'm not going to mess up my proportion. It would be easy to do something like this: 14x and 1,000 400. All right, I got the same numbers, 1,400, 14x. That seems right. But notice what you're doing here. You're doing 14 times 1,000 divided by 400, and over here 400 times 14 divided by 1,000. You're going to get two very different numbers. So that's 14 times 1,000 is 14,000 divided by 400. It's going to give you 35. So your answer is x equals 35. And something I've been ignoring but you should be doing, especially on your MSA, is if you convert both sides to decimals, 14 over 400 gives you, oh look at that, 0.035. And what's 35 over 1,000? Again, 0.035. When you have a proportion, both sides of your proportion, if you convert your final numbers into decimals, they should be the exact same decimal on both sides. Number 7. Ansi drives 125 miles in 2 3/5 hours. At the same rate, how far will he be able to drive in 6 hours? What are we comparing here? We're comparing miles. Well, actually, we're comparing distance to time. This is just speed. Distance over time. All right. So Ansi drove 125 miles in 2 3/5 hours. How far? Okay, so how many miles will he travel in 6 hours? Ta-da! 6 times 125. 6 times 125 is what? 750. And then 750 divided by, that's 10, that's 13 over 5. 13 over 5, which would be times 5 over 13, and 750 is 750 over 1. So 750 times 5 is a fun number, 3,750 over 13, and then we divide that by 13, and we get 288.46 miles. And there we are. Number 8. A piece of cable 8.5 centimeters long weighs 52 grams. What will a 10 centimeter length of the same cable weigh? Uh-oh. I just realized number 9 has a problem with it. Ah, okay. A piece of cable, blah, 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 blah. All right, what are we dealing with here? 8.5 centimeters to basically length to grams, right? Length to weight. Length to weight. That's our big picture. Length to weight. So, what's the length? 8.5 centimeters to 52 grams should equal, what will a 10 centimeter length of the same cable weigh? 10 centimeters, that's the length, to an unknown weight. There we go. 10 times 52 is 520. 520 divided by 8.5 equals 520 divided by 8.5. Ugh. Really? 61.1, we'll round it up, 18 grams. So X equals 61.18 grams. You don't have to do number 9. I took it away. I didn't give you enough information to solve the problem without looking stuff up on the internet.